Okay, so again, I recommend following these steps. They give you clear organization about what is expected for this question. So as always, the domain for a polynomial is going to be the set of real numbers. To apply our leading coefficient test, now our leading coefficient is not explicitly written. What we do in a question like this is we essentially imagine what would it look like if we multiplied out. I do not expect you to FOIL this out. I want to be really clear on that. That is not a necessity in this case. So what I would recommend is what would happen if you multiplied really kind of the biggest numbers of each group. So that would be this t and this t, but taking into account the fact that they're both squared. So there's no other kind of coefficient in front of this t, so this would give you a t squared, and this would also give you a t squared. So multiplying them by each other would give you a t to the fourth, and you have this negative 1/4 sitting out front. I hope that idea makes sense. If you don't like it, I guess your only alternative would be really to FOIL the whole thing out. So your leading term is going to be this negative 1/4 t to the fourth. That is even, and it's negative, which means we're facing down. So again, we're kind of trying to figure out what happens in those middle, dots, because we just don't know. We just know the end behavior, right? So check and check. So let's look at our real zeros, right? Which again means we're going to set, or we're going to be looking at what happens when we set this p of t equal to 0. So pay attention to the variable change. T just replaced x. Remember, we call that the independent variable. It kind of stands on its own. So I've got negative 1/4 times t minus 2 squared and t plus 2 squared. This is actually a really great one because it's already set equal to 0. We don't have to do anything. And it's already factored, right? So technically you get this negative 1/4 is 0. This is your zero product property. This is not a true statement, right? So we kind of just toss it. And that's really just because it's just a coefficient, right? It's just a leading coefficient. You've got t minus 2 quantity squared is 0, or I guess I should have an or in there. You've got t plus 2 quantity squared is 0. So if we were to kind of clean this up, we would take the square root for both of these of both sides. Normally, when you square root both sides, you do have to consider a plus or minus. But because we have 0 on the other side and there's no such thing as a positive or a negative 0, 0 has no sign attached to it, we just end up with t minus 2 is 0, which means t is 2, remembering its multiplicity 2. And then you end up with t plus 2 is 0, which means t is negative 2, also multiplicity of 2. Right? So these two together represent both the x-intercepts and the real zeros, right? Those things are synonymous with each other, okay? So now what we want to find, I can see myself a bit. Now what we want to find is our y-intercept. Right? This is the fourth step. And this happens when we plug 0 in. So f of 0, I should say p of 0, excuse me. P of 0 is equal to negative 1/4. We've got 0 minus 2 squared and 0 plus 2 squared. So it's negative 1/4. This is going to be negative 2 squared is 4. Positive 2 squared is also 4. One pair of those will cancel, and we're still left with the other pair, so negative 4. So your ordered pair is 0, negative 4. So if we bring out our graph, And I'm going to graph my two pieces so far. Right? So both of these, we do know, just kind of rough sketching here, we do know that both of our sides are facing down. I guess I should do that, right? Both of our sides are facing down. But at each of our zeros, we're tangent. So it's going to touch and go down, touch and go down. So we kind of have this like upside down W graph that we're expecting. But again, we should verify it with actual points. So if we pick some points, maybe to the left of -2, we can try -3. So f of -3, this would be step 5, other points. F of -3, you've got -1/4, -3 minus 2 squared, -3 plus 2 squared. So you've got -1/4. This is -5. If you square it, you get 25. This is -1. If you square it, you get 1. So that is -25/4, which I usually think is helpful as a mixed number, just so you can approximate. This would be -6.25. So -3. Other points we can try, well, we need something between -2. I mean, you could say between -2 and 4. I do feel like it's kind of like we can kind of see where it's going, but it doesn't hurt to plug in more points. So let's try f of -1. I'm gonna scoop this up so we can see it a little better. And so that would be -1/4, -1 minus 2 squared, -1 plus 2 squared. So -1/4, this would be -3 squared, so that's 9, and this would be 1 squared, which is just 1. So that's -9/4. And that, again, if you kind of give a mixed number, is -2.25. So -1, -1, -2, and 1/4 would put it just over. You'd be right about there. I would do, we already have 0. I would do the counterpart on the other side. So let's plug in a 1 and let's plug in a 3, just for some symmetry here. So f of 1 is going to be -1/4. You have 1 minus 2 squared, and you have 1 plus 2 squared. So -1/4, 1 times -2 is -1, right? If we square that, it's just 1. 1 plus 2 is 3, and if we square that, we get 9. And notice we get the same exact answer, right? So this is -2.25 also. So you kind of have this mirroring on the other side. Okay, last but not least, let's try f of 3. And I suspect it's going to look similar to what we did up here. So you've got your -1/4. 3 minus 2 is just 1. And if you square that, you get 1. 3 plus 2 is 5. If we square that, we get 25. And you get that same answer, -25/4, which is -6.25. So if we connect all of this, kind of like the letter M, give or take, hopefully a little less wobbly. All right.